Geometry, Unit 8. This one is actually from Chapter 9, Section 6. And we're looking at our Section 8 of Unit 8. Circles and the Pythagorean Theorem. Circles and the Pythagorean Theorem. So we know from everything we've done so far in this unit that when we're dealing with radius, chords, and tangents, there are a lot of right angles, which means Pythagorean theorem can be used when there's a triangle. We also can use, potentially, our special right triangles, the 45, 45, 90, or the 30, 60, 90 triangles. So here, in this first circle, we know that the radius, when it intersects a chord at a 90-degree angle, it bisects the chord and it bisects the arc. And when we're dealing with tangents, we know if you draw the radius to where the tangent intersects the circle, it's also a right angle. So we have these two right angles, so we can potentially use a lot of things related to right triangles. So here, let's look at this problem. So we're given that the radius intersects the chord at a 90-degree angle, so that means these two are congruent. All right, so we've got a right angle. Let's use the Pythagorean theorem. Let's see if we can solve for the length of AC. So x squared plus 16 squared equals 25 squared. So x squared equals plus 256 equals 625. Subtract, take the square root. We get the square root of 369, which if we simplify is 3 square root of 41, or 19.2. I rounded it. So AC is 19.2. Now we know the length of CD plus this length is the radius. So AD is 25. So to find the length of CD, we take 25 and we subtract 19.2, and that length is 5.8. And then the length of CE, we know BC and CE are congruent, so CE has to be 16. All right, so let's solve this one. We're given the radius is 5. Well, we know this is a right angle, and we also know this is 5. So this full length is 13. So 5 squared plus x squared equals 13 squared, and that ends up being 12. 5 squared plus 12 squared equals 13 squared. We've done that enough times, everyone should know that. Now let's do this one. Again, we know the tangent is perpendicular to the radius, and so that means this angle is 60 degrees. Now this is a 30, 60, 90 triangle. We should remember that the short side here is related to the side that's crossing the 60 degrees. And they're related by the square root of 3. So I'm going to take 40 divided by the square root of 3. Now let's find the area. So the area is pi r squared. So it's pi, our radius is 40 divided by square root of 3 squared. And so that's going to be 1600 over 3 pi. And then our percentage, I've got 60, so I want the area of this shaded region. So instead of 60, we have this as 300. So this is 300 divided by 360, which is 5 over 6. So now we multiply these. So 1600 over 3 pi times 5 over 6. And we get 8,000 over 18 pi, and we can simplify that to being 4,000 over 9 pi. And that is the end of this lesson.